All right, today we're going to dive deep, really deep, inside the human body. We're going to explore these incredible microscopic engines that power your kidneys. We're talking about nephrons. These tiny little filters are doing an absolutely colossal job. So let's get right into it.
So this brings us to the big question for today. Think about it. If all your kidneys' filters are basically doing the same job, cleaning your blood, you'd think they'd all be the same design, right? Just copy and paste a million times. Well, it turns out nature had a much more elegant and way more specialized plan in mind. Okay, so before we get any further, let's just make sure we're all on the same page. What is a nephron? Well, simply put, it's the tiny microscopic filtering unit of your kidney, and you've got about 1 million of them in each kidney, all working tirelessly. You could say they're the real heroes of our story today. All right, now let's get to the heart of it. Let's meet the two different types of these tiny engines. And as you're about to see, they are definitely not created equal, not in their numbers and not in their design.
And wow, this chart just lays it all out, doesn't it? Look at that split. The vast majority, we're talking about 85%, are one type, the cortical nephrons. And then you've got this small slice, only about 15%, of the other kind, the juxtamedullary nephrons. Right away, that massive difference in numbers, well, that's our first big clue that something different is going on here.
So let's start with the big one, the overwhelming majority. We're going to call the cortical nephron the workhorse of the kidney. Why? Because this is the one doing most of the day-to-day heavy lifting filtration. So, what makes it the workhorse? Well, like we just saw, there are a ton of them, about 80 to 85% of the total. Their little filtering units, the renal corpuscles, are located in the outer part of the kidney, which is called the renal cortex. But here's the really crucial part, the key design feature. They have these short little loops, the loops of Henle, that barely even dip down into the next layer of the kidney, the renal medulla.
And this diagram shows that structure perfectly. Just look at it. You see how the main body of it is sitting up high in the cortex? And then look at that little loop. It just barely dips down. I want you to burn that image of the short loop into your brain. It is absolutely key to understanding what this nephron does.
Okay, so we've met the workhorse. Now it's time for the specialist. Let's meet the other 15%, the highly specialized juxtamedullary nephron. And if the cortical is the workhorse, think of this one as the conservation expert. Yeah, they might be small in number, only about 15 to 20%, but don't let that fool you. Their role is absolutely vital. This small group holds the key to one of our body's most critical survival functions, the ability to conserve water.
So, what's their secret? What makes them so special? Well, for starters, their filtering units sit way deeper in the cortex, right up against the medulla. But here's the biggest difference, the real game changer. They have a really, really long loop of Henle. And not only that, they have a whole special network of blood vessels, called the vasa recta, that runs right alongside that long loop. That's a critical part of their design.
All right, so we've met our two players. Now let's do the obvious thing and put them side by side. You're going to see just how different their designs really are. The contrast is, well, it's pretty stark. And there you have it. Just look. On the left, you've got the cortical nephron. It's short, it's compact, it's barely leaving the cortex. Now, shift your eyes to the right, to the juxtamedullary nephron. Do you see that incredibly long loop? It's plunging deep, deep down into the renal medulla. That one single structural difference, it changes everything. And this table just nails the summary. Location, different. Loop length, totally different. How deep they go into the medulla, different. Even their blood supply is different. They are just fundamentally different designs, which of course brings us right back to our original question, why? Why all the trouble?
Okay, this is it. This is what we've been building up to. Let's finally connect these huge differences in structure to what they actually do. It's time for the big reveal.
So what is the big deal with the long loop? Really, why would evolution go to all the trouble of creating this second, much more complex design? What does that long loop do that the short one can't?
The answer, it's all about that loop. That long loop is a masterpiece of biological engineering. It is the one thing that allows your body to conserve water by creating super concentrated urine when you need it most. And that really is the bottom line. The long loops of Henle are what enabled the kidney to produce really, really concentrated urine.
The everyday cortical nephrons, they handle all the bulk filtering, sure, but when your body is stressed, when you're dehydrated and you need to hold on to every last drop of water, that's when the juxtamedullary specialists and their amazing long loops step in and get the job done.
So there's our answer to the question we started with. We don't have one design, we have two, because our kidneys have two very distinct, very vital jobs. You've got one for the everyday filtering, and you've got a specialist for water conservation in extreme situations. It's just a beautiful, perfect example of form following function. You know, this whole story of the two nephrons is such a fantastic reminder that our bodies are just filled with these specialized tools for specialized jobs. It kind of leaves you wondering, doesn't it? What other elegant, incredible designs are hidden away in our own biology just waiting to be explored?